Welcome, ladies and gentlemen. My name is Brian McLogan, and in this video, we are going to work on classifying conic sections. Now, this is actually the first section in our chapter for analytic geometry, also known as conic sections. Now, what I'm going to do is work through the exact same notes that I gave my students inside of the classroom. And in this lesson, what we are going to cover is obviously classifying conic sections, but we're going to learn how to identify the conic section based on the standard form, as well as be able to identify the center or the vertex. We're going to talk about converting from general to standard form by completing the square, as well as how to identify the conic from general form. Now, if you're new and you're not familiar with conic sections, I will get into the different types of conics, where they come from, their shapes, as well as their equations. But before I do that, I wanted to practice with these students the completing the square, because this is something that gives a lot of students a lot of trouble. And it's something that we've covered previously in this course, but something I wanted to kind of circle back with before we really get into working through a lot of problems today. So what I did is I started the lesson off with basically 6 completing the square problems for students to kind of work on. And I kind of just went through a little bit of difficulty, level 1 through level 6. And I gave them kind of 5 minutes to kind of see how far they could go. And so what we're going to do is we're just going to kind of work through them. Now, if you've completely forgot about completing the square, which many of my students will be at that exact same pace, I'm just going to do a quick little review for you. So again, the idea of completing the square, but again, this is not going to be a very in-depth review, okay? It's just going to be a quick little review. So the idea of completing the square is to take a quadratic from standard form to vertex form. And the reason why we want to do that is because we can easily identify the vertex, in this case, as h, comma, k. Okay, and that's going to be something that's going to be pretty important in terms of a parabola, finding the vertex, as well as for the center for our other types of conics, and we'll talk about that later. So what we need to do, if you understand the difference really between these two forms, is this has a binomial squared, right? You have a binomial raised to the second power. So how does that come? Well, that comes from having a perfect square trinomial. So completing the square is really the process of creating a perfect square trinomial. Now in this first example, you can see actually we have a perfect square trinomial. Now, how do I know this is a perfect square trinomial? Well, because a perfect square trinomial is a trinomial that, when factored down, has a binomial times itself, right? X plus 1 times x plus 1 gives us x squared plus 2x plus 1. So therefore, I can rewrite this as an x plus 1 quantity squared. So you can see, just by factoring this case, I took this quadratic, and then I took this quadratic in standard form, and by factoring that, I rewrote it as a binomial squared, which is now in vertex form. And now I can say the vertex is going to be -1, comma 0, okay? And you can see the reason, again, just kind of going back to that formula, remember it's the opposite value of h, comma k is going to go ahead and give you your vertex. Now in the next example, this is not a perfect square trinomial, all right? So what we're going to want to do is kind of like say, all right, what value c, a lot of times you give it the value c, that constant, what constant could I add that would create a perfect square trinomial? And this is where students usually kind of get a little confused. So let's just start writing down a list of perfect square trinomials that we are aware of. Well, obviously we have x squared plus 2x plus 1. We just did that one. And again, instead of x plus 1, what if it was x minus 1 times x minus 1? Well, then that perfect square trinomial would be x squared minus 2x plus 1. Okay. So what if these were both 2's? Well, then I'd have x squared plus 2x plus 4. And then if they were both -2's, if it was like x minus 2 times x minus 2, then I'd have x squared minus 4x. Oops, I'm sorry, that's supposed to be a 4x, isn't it? Then I'd have x minus 4x plus 4. And you can see here, I have that and I have that. Those are the same. So if I just add a 4, so what I like to do here is if I group these first two terms, and if I add a 4, I have now created a perfect square trinomial. I have completed the square, right? I've completed a square trinomial. So now I can rewrite that as a binomial squared, but we have to stop and realize we just can't randomly add a number to an equation here. We have to make sure if we're adding a number that we either add it on both sides or add and subtract it. So remember, you still have the 5. So I'm going to add a 4 and I'm going to subtract a 4. However, with this perfect square trinomial, I can rewrite that as an x minus 2 quantity squared. and then negative 4 plus 5 is going to be a positive 1. Now you can see that my vertex here is going to be 2, 1. Again, using the opposite value 2, and then k in this case is going to be my 1, which will be the same sign. So if you have a good sense of perfect square trinomials, you could just do, x squared plus 6x plus 9. X squared minus 6x plus 9. And really, a lot of the problems we're going to be using the same numbers over and over again, right? So, I mean, if I could just kind of get through these just really quick, 8x plus 16, you're basically going to see these perfect square trinomials, the same ones over and over again. Now, obviously, these are not the only perfect square trinomials. As you're going to see, as we move up to the different levels, it gets a little bit more difficult. But again, here's just a good idea of our perfect square trinomials that we're going to use the most often. So the next one you can see here is I have a 6, right? Now, one thing though that we need to remember here is, in this case, this is not going to be as easy completing the square, because when we're completing the square, we have to create a perfect square trinomial when a is equal to 1. I'm sorry. So if I have a coefficient of my x squared, I need to factor that out. All right. So I don't want to deal with, finding this perfect square trinomial with a positive 6. I have to rewrite this as a negative x squared minus 6x minus 2. Okay, so now I can just kind of go back up here and I say, okay, x squared minus 6x, I need to add a positive 9, right? And so what I'll do is I'll add a positive 9. And then just remember, you have to subtract 9. However, we have to be careful here, and this is where a lot of students have trouble. Again, if you're adding a 9 here, you're not really adding a 9 inside the parentheses. You're adding a 9 that's being multiplied by a negative 1. So if you subtract a 9, you also have to multiply that by a negative 1. Again, now this produces a perfect square trinomial, which is going to be x minus 3 quantity squared. Again, I'm just doing factoring. Negative 9 times negative 1 is a positive 9. Minus 2 is going to be a positive 7. My vertex in this case is going to be a positive 3, 7. In this problem, we're going to do the exact same thing. I'm going to factor out a 2 first, just like how I factor out a negative. By factoring out a 2, I get an x squared minus 4x plus 5. I'm not going to want to factor out of the 5 because, again, I need to create a perfect square trinomial, right? So I have this negative 4x. I know I need to add a 4 to create the perfect square trinomial. And then just remember you subtract 4. But again, we're not really adding a 4 inside the parentheses, right? You didn't just add a 4 here. You added a 4 that's being multiplied by 2. So when you subtract the 4, you need to multiply that by 2 as well. So y equals 2 times x minus 2 quantity squared. This becomes a negative 8 plus 5 is going to be a negative 3. Now my vertex is going to be a 2 comma negative 3. And some might be wondering, well, what about this 2? What about the negative? What are they doing? Well, those are going to be, if you remember from our transformations, those are going to be vertically stretching and compressing the graph as well as reflecting. So that's going to be a reflection, and this would be a vertical stretch, but they're not going to impact actually the vertex. All right, so now let's get into the problems that become a little bit more difficult here. So identifying the perfect square trinomial in this case is a little bit more confusing, right? If you realize 3 is not one of those middle terms. So what can I do in this case? Well, actually, you could do the same process over here. And hopefully what you recognized is when you are completing the square, another way to find that value c that creates the perfect square trinomial is to take your middle term b divided by 2 and square it. And again, let's check that. Is 2 divided by 2 squared equal to 1? Yes. Negative 4 divided by 2 is negative 2. Negative 2 squared is 4. Negative 6 divided by 2 is negative 3. Negative 3 squared is positive 9. And you can see again that obviously equals 4. So in this case, if I don't recognize the perfect square trinomial, which again, totally realize a lot of students are not going to recognize the perfect square trinomial here. So again, just remember you can always take b divided by 2 and square it. And that's always going to give you the value c that completes the square. So in this case, I'll have negative 3 divided by 2 squared, which equals a 9/4. So I have y equals x squared minus 3x plus 9/4. Now again, remember, if you're going to add 9/4, you have to make sure you subtract 9/4 and then minus 1/4. Now again, this creates a perfect square trinomial. And the nice thing about doing this is when you are trying to find your binomial squared, if you have your b, it really depends on whatever your b divided by 2 is, if it's plus or minus. All you're going to do is take x plus or minus b over 2 squared. So since my middle term is negative, I know that this is going to come in the factored form of x minus my b divided by 2, which is a negative 3/2. Or again, you could just really take negative 3/2. So that's a negative 3/2. And then this is going to be a negative 9/4. That's supposed to be a plus, sorry. And then that becomes a negative 8/4, which is 2. So this problem actually has x minus 3/2 quantity squared minus 2. So my vertex is actually not that bad. It's just going to be a positive 3/2, positive 2. All right, and the last example here is, again, we need to factor out the 3. Now, again, 3 is not divisible by 2, so we're going to want to write that as a fraction. So if I factor out a negative 3, I have an x squared plus 2/3 x minus 1. Okay, and again, you can always check your answer. Oops, don't want to multiply it by both of them. Let's just factor the 3 out from there. Now, again, negative 3 times x squared, right? If you were to multiply that back through, you'd get the exact same answer, right? And actually, I apologize, that should be a negative. That's why you check your work, right? So now we're going to take our b, so negative 2/3 divided by 2 squared. Now again, remember dividing by 2 is the same thing as multiplying by 1/2, which is really just going to be a negative 1/3 quantity squared, which is 1/9. So y equals a negative 3 times x squared minus 2/3 plus 1/9. And then I'm going to want to subtract 1/9 and then minus 1. All right, so in this case, again, it's just going to be my b divided by 2, which is going to be a negative 1/3. And again, makes sense. Does negative 1/3 times negative 1/3 give you 1/9? Yes. Does negative 1/3 plus negative 1/3 give you negative 2/3? Yes. But again, be careful though, real quick. I caught myself on this mistake. You're adding a 1/9, so you subtract a 1/9, but you're not really adding a 1/9. You're adding a 1/9 that's being multiplied by a negative 3. So when you subtract a 1/9, you got to make sure you multiply that by a negative 3 as well. Okay, so this can now be factored down into an x minus 1/3 quantity squared. And then this is going to turn into, that's going to be a positive 1/3 minus 1. So again, that 3/9, which is 1/3 minus 1. So therefore, that's going to give me a what? A negative 2/3. So y equals a negative 3 times x minus 1/3 squared minus 2/3. So now my vertex in this case is going to be a positive 1/3, negative 2/3. Whew, there you go. So again, just a little bit of advancement. Obviously, you can see that we just kind of worked our way up from the most basic to a little bit more advanced, completing the square. All right, so now let's get into the different types of conic sections. So the first one, obviously the reason why we spend a lot of time with completing the square is going to be the parabola. Now, one of the things I show students is I give them a cone and I kind of show them like how the parabola, the shape comes from. Obviously, I don't have that availability here at my home studio, but that is one thing that I kind of show students as far as the, slice of the, if you were to basically take this and slice it, you'd be able to see, this is really difficult to kind of do, but you would see that parabola, how the parabola shape is kind of formed there. And actually, it would kind of look like that. Yeah, so it's kind of difficult to kind of show that picture. But either way, let's just kind of go through our standard form because there's something new here that we have. So up to this point, we have been familiar with, and actually I'm just going to erase that. That's just horrible. So obviously the parabola is just going to be a conic section. My students, when you look at a cone, you'll see it's kind of go through a little bit easier. But typically, we have already talked about ax squared plus bx plus c. And then we've talked about y equals, a times x minus h quantity squared plus k. Okay. In this case, a, b, and c were just our coefficients, or constants. In this case, h and k represented the vertex. That's going to be the exact same thing for our standard form of a parabola and conic sections. The only difference is we're going to have p, and we're not going to talk about p today. I just want you guys to see these new kind of formulas. The important thing I want you to see about this, though, is that we can have a parabola that's going to open up, open down, Or we can now have a parabola that's going to be opening up to the right or to the left. Okay? And so that is really going to be dependent on this value of p. If p is positive, it's kind of like our a in this case. That means our x squared here is going to be opening up. If p is negative, that means it's going to be opening down. Now, again, that's when x squared is, right? So you should hopefully be familiar with when x squared, like that's a quadratic, right? Or what you're familiar with. So the y squared, notice these are not functions, right? So we're not actually doing a chapter on functions. So these don't pass the vertical line test, which is fine. But again, if p is positive, the parabola is going to open up to the right. And if p is negative, it would open up to the left. The main thing we really want to identify is h and k is going to represent your vertex. It doesn't matter how the parabola opens up. That is going to represent your vertex h and k. Okay, so all I wanted my students to do in this case was just identify the parts. So just find the vertex. Don't worry about the value of p. Basically, in this case, we just want to find we do want to find p. So we don't know what p is right now, but we're just going to find p. So first one, if you have this x minus h, Conic squared equals 4p times y minus k, right? So that's the formula that I just gave you, right? You can see x is squared. All right, so in this case, we can recognize my vertex to be 2, 1. Again, remember, it's x minus h, y minus k, right? X minus 2, y minus 1. So h is 2, k is 1, right? They're not negative 2, negative 1. It's positive 2 and positive 1. P in this case, we have 4p is equal to 4. So you divide by 4 on both sides. You could say p is equal to 1. Okay, and that's it. On the next one, you can see y squared, but again, that's okay. If we were to write this as y minus k, quantity squared equals 4p times x minus h. So again, obviously, x is not being subtracted by anything, so you could rewrite this as x minus 0 if that makes you feel better. But in this case, our vertex is just going to be 0, negative 1. Notice how I'm using the opposite sign here, right? Because it's y, you could also think of this y minus a negative 1 quantity squared, okay? So just to remember that, a lot of students still kind of have trouble with that, even up to this point. And then our p, in this case, I'm just going to take 4p equal 3. Divide by 4, p equals 3/4. And that's it. Okay. And the last example, again, just another formula here where, again, if I just write this as x minus h quantity squared equals 4p times y minus k. Hopefully you can see that the vertex here is 0, 0. And 4p looks like it's going to be equal to a negative 1, right? If there's not a number there, it can be negative 1. So you divide by 4 on both sides, and p is equal to a negative 1/4. Okay? I'll just write it twice, I guess. I guess that's pretty much everything we need to kind of cover. Again, just really identifying the couple things. Actually, here's the couple points I wanted to make. Notice how if it's a parabola, I either have x squared or y squared, right? So, I mean, that's kind of a obvious point here. When x is squared, obviously we know what those graphs look like, or if y is squared, it could be one or the other. But just note that either x or y is going to be squared because that's not always going to be the case. And then also just kind of notice that h is always with x and k is always with y. That's something that's going to be consistent for the rest of this chapter as well. All right, so then we get into the circle, which hopefully from geometry class is also something that you are familiar with. So now in this case, notice that the x and the y are both squared. H again is with x, k is again with y. Those are going to represent the center. So instead of the vertex, they now represent the center, and r represents the radius. So again, if we just had a circle here, just remember that is your h and that is your k. And the distance from your center to any point on the circle is going to be your r. Okay? So again, that can be moved around, horizontally shifted left to right. And then, find r, which is basically, again, going to be the distance from the center or the equidistant for all the points that make up the circle. So just kind of, this is really hopefully good to review. We've already kind of covered this a little bit as well in our last chapter, but really anybody from geometry hopefully can recognize, again, all we're really trying to identify is, from the standard form, x minus h quantity squared plus y minus k equals r squared. So we just want to find what is your h and k and what is your radius. And again, just make sure you have that x minus h, the y minus k version there. So again, this is going to be a 1 comma negative 1. And then where r is equal to 3, which represents the radius, right? Because again, remember r squared is equal to 9, so r equals 3. In this case, again, we could write this as x minus 0 quantity squared plus y plus 1 quantity squared. And again, big mistake, a lot of students don't want to take the square root of 5, so let's say r is equal to 5. So again, just remember that that is, equal to your r squared. So r squared is equal to 5. So r is going to be the positive square root of 5. Even though you're taking the plus or minus, that square root, we don't need to include the negative value of that. So in this case, I'll have 0 comma negative 1, where r is equal to the square root of 5. Now, it's the last example. If you notice that for my x and my y, both have a coefficient of 2, right? And in our general formula, we don't have coefficients here. So what we're going to want to do is divide both sides by 2. When divide by 2 here, that's going to eliminate those 2's on the left-hand side, and then 8 divided by 2 is going to be 4. So that's going to give us the equation x plus 3 quantity squared plus y plus 3 quantity squared equals 4. Now we can identify that the center is going to be negative 3, with a radius of 2. Okay, so again, if you have some extra numbers or something going on, just make sure you either divide them out. So therefore, these coefficients of your x and your y squared are going to be at 1. All right, now let's go and look into the next one, which is going to be the ellipse. So the ellipse is very, very similar. Very similar to the circle. It's obviously just going to be a, sometimes a lot of people, when they first see it, they call it the oval, right? But basically it's like a circle that's been elongated either on a horizontal or a vertical axis. So that, if we have a circle, if we elongate it horizontally, then it's going to look something like this, right? Or we could elongate it vertically. Okay, and how it's going to be elongated is going to be what these values a and b represent. Because again, you notice that the values all the way, like it doesn't have a radius, right? None of these points are going to be equal distance all the way around. So that's where our values a and b come from. Now again, we're not going to find the values. We're not going to worry about describing the values a and b at this point. All I simply want to do is just make sure you understand how to identify the center, which is going to be your hk, and the values for a and b. And that's it. Okay, so all we're going to do is let's just identify the center and the values a and b. Simple as that. So in this case, we can see that, again, we could write this as x minus 0 quantity squared plus y minus 0 quantity squared over 3. Oops, I'm sorry. Getting a little ahead of myself. Over 9 equals 1. So therefore, my center, did I write vertex in that last one? I always do that. No, I didn't, but I didn't label it. That's the center, center, and center. Okay, I'm sorry. That's just one of my pet peeves that I'll keep on writing the center as the vertex. So in this case, the center is going to be at 0, 0. Now, you actually don't know which one is a squared or which one is b squared, do you? How should I teach that without teaching from there? You know what? Let's just let's forget about identifying a and b in this case, because you don't really know which one is which. Actually, no, we could kind of do this. Yeah, where a is going to be greater than b. Yeah, let's just do that. Okay, so I'll add that in there. So a is going to be always larger than b. So in this case, I can say that my a squared here is going to be 9. So I could say a squared is equal to 9. That means a is equal to 3. And b squared is 4. Therefore, b is going to be equal to 2. In next example, you can see I don't have any fractions here. But again, my x squared and my y squared have coefficients. So what I'm going to do is I'm going to divide. Actually, I'm sorry. Before I get to that, they don't have coefficients here. So I know I'm going to have to divide them out. But what should I divide them by? Well, if you look at the formula, you can see that both these equations are equal to 1. So actually, what I'm going to want to do here is divide by 16 on both sides. But I'm going to want to start over here because I need that to be a 1. So I divide by 16 on both sides. Remember that 16 distributes into both of those terms. So that's going to leave me with an x minus 4 quantity squared. That's actually just going to go over to 1. But I'm going to write that in there so you know it's there. And then 4 over 16 can be reduced to 1 over 4. 1 over 4. So I'd have a y squared over 4 equals 1. Okay, and now you can, again, see that I don't have a value for y, and that's perfectly fine. But my vertex here is, no, see, I did it. I told you I was going to do it. My center here is going to be 4, 0. And then my a squared is equal to 4. So therefore, a is equal to 2. And my b squared is going to equal 1. So b is equal to 1. Okay. So again, you're basically just recognizing that these denominators are your a squared and your b squared. But remember, a squared is always larger than b squared from that formula that I added in. All right, and then last but not least, ladies and gentlemen, is the hyperbola. So in this case, the standard form of the ellipse of the hyperbola. So I'm not sure. So I actually didn't go through these notes with my class first. We actually are doing these notes first, but this is actually the exact same lessons and problems that I did previous years. So I just kind of oversaw some of these corrections or mistakes. But again, the equation of the hyperbola here, where you can see that basically the really only difference is the a squared and the b squared don't change, and that we're dealing with subtraction instead of addition, right? So we're finding the difference here. Now, for the hyperbola, that's going to be kind of like it's going to be like two parabolas facing away from each other. And again, that can look like they can be vertically facing away from each other, or they can horizontally be facing away from each other. Okay. So kind of like the same idea, we're going to be dealing with, either vertical hyperbola or a horizontal hyperbola, just kind of the same thing like an ellipse. It can be a horizontal ellipse or a vertical, ellipse. And again, we'll talk more about that as we actually investigate hyperbolas for a whole day. But for right now, I just wanted students to recognize, again, the center and A and B. Notice how A is always first and B is always second. So in this case, my H and my K here, my center is going to be 4, negative 2. My A squared is going to equal 5, and my B squared is going to equal 9. So therefore, A equals square root of 5, and B equals 3. Because again, we want to find our values A and B. Now again, this one's equal to 1, so that's perfectly fine. However, we don't really want this 3 to be in there, right? This is kind of like confusing that portion. So again, actually, I don't know why I did that. Do I really need my students to know that? No, I do not. Did I want that? I don't know. Well, either way, I'll leave it in there. But just remember that 3/2 or multiplied by 3 divided by 2 is really the same thing as just if I leave that out there and I just rewrote that as a 2/3. Okay. So yeah, I guess it's actually kind of important. Sometimes this does happen where we'll see an equation that instead of, you'll have a coefficient there, like will be written in that form, but really that just recognizes that our term down below is not really 2, but it's actually 2/3. Because if I were to simplify this, I could rewrite it as 3/2. So in this case, anyways, my center, now again, make sure that you recognize that H is with X and K is with Y. So in this case, we have -1, 0. My A squared is always first, which is 1. And my B squared in this case, which is going to be a 2/3. So A will equal 1. And here I'm going to have B is equal to the square root of 2/3. Kind of a little odd, but again, that's perfectly fine. All right, so that was just identifying the center, the vertex, as well as the parts such as A and B and P. We'll get into that a lot more in depth later. For right now, I just wanted students to kind of practice that. But now we're going to get into, identifying the conic based on the formula in general form. So you can see when I gave you those formulas, right, they're all kind of similar to each other. You can see the hyperbola had subtraction, right? The ellipse had addition, And the circle obviously was addition, but there was no denominator there, or at least the denominator would be the same as r squared. And then the parabola basically had an x or a y squared. So a lot of times we'll be given a conic in general form, and if we want to identify the parts, we're going to need to practice completing the square. Now, for this case, we're not going to be worried about identifying the parts, but what we're going to want to focus on is finding the center to classify. Yeah, well, in this part, we're just going to practice completing the square, and then to identify if it is a parabola, a ellipse, a hyperbola, or a circle. And you can see I chose 4 problems, and guess what? We're going to have one of each. All right, so let's kind of get into it. The main kind of takeaway when you're looking at completing the square when you only have 4 conics in general form, when you only have an equation with 1 squared, you kind of know it's a parabola. Like I only have this 1y squared. And what I'm going to do then is I'm going to get the x's and the y's on opposite sides. So if I add an 8x and add a 31 to the other side, here, let's write that. Because again, if you look back at those 2 formulas, you'll notice that the 8x, or the x's and the y's, are on opposite sides. So I have y squared plus 6y is equal to a 8x plus 31. Okay. Now again, we need to complete the square here. Hopefully you can recognize that this is I have a 6 in the term. So to create a perfect square trinomial, I'm just going to add a 9. But again, you just can't randomly add a 9, right? If you're going to add a 9, you have to add and subtract a 9, or you can add and subtract a 9, or you can add a 9 on both sides. And you can see that's what I'm doing in this case, adding 9 on both sides. Here, I have now just created a perfect square trinomial that's factorable. And then here, you can see I can add the 9 to the 31. So that's going to be a 8x plus 40. And therefore, you can also just factor that out to y plus 3 quantity squared equals a 8 times x plus 5. Now this would be in a format that we'd want to identify, that we could identify the vertex, the value of p, and all the other stuff that we'll need. But for right now, we just want to label this as a parabola. Okay. Now in the next one, hopefully you recognize that this has an x squared and a y squared. So hopefully you can see that this is not going to be a parabola. So what we're going to want to do in this case is keep the x and the y's on the same side, but now what we're going to want to do is just group them together. So I'll have an x squared plus 6x minus a plus a y squared minus 4y. And then what I will do though is I'll put the 15 to the other side. Okay, now we're going to do the exact same thing, but now we're going to complete the square for the x's and complete the square for the y's. And again, my whole goal is hopefully you recognize these to be your perfect, easily create perfect square trinomials. We just did this one for y's. So hopefully you can see that, oh, you don't need to do b divided by 2. And again, what is b divided by 2 squared? 6 divided by 2 is 3. 3 squared is 9. Okay, but again, just remember when you add 9, make sure you add 9 to the other side, right? So then it's a plus. Here we have a y squared. What's going to create the perfect square trinomial when my middle term's a -4? Well, that's going to be a positive 4. So just make sure you add a 4 over there as well. Now again, this can be factored down into an x plus 3 quantity squared. This can be factored into a y minus 2 quantity squared. And again, I'm really just using those perfect square trinomials I had at the beginning of this lesson. Now I can add these up to give me, let's see, that's going to be 19. That's going to be a 19. That's going to be a 28. And then in this case, I could see that, well, yeah, you could divide by both of them, but then they both have the same denominator. They both have the same denominator, right? So the a and b wouldn't have any difference. So you can see that this is actually going to be a circle. Okay, so when obviously they'd have the same denominator here, you can see that that's going to create your circle. Okay, so for the last set of examples, you can see that these look a lot more confusing. But again, if we just follow the same process that we did before, you can see that these are not without of our reach. But yes, they are a little bit more confusing than the problems that we just did. But the first thing we're going to want to do is, again, organize our x's and our y's, or at least combine our x's and our y's. So in this case, I'll have a 25x squared plus a 50x minus a 16y squared minus a 96 plus a 281, which I'm going to set to the other side. So that's going to be a negative 281. Now, again, the whole point of this is, again, if we're going to want to complete the square, we're going to want to factor out those common terms, right? So in this case, I can factor out a 25. And by factoring out a 25, that's going to leave me with an x squared plus 2x. Now, hopefully you recognize I can create a perfect square trinomial there. And then over here, I'm going to want to factor out a negative 16, and that's going to leave me with a y squared. 16, that's going to be what? 60, 36, that'd be a negative 6. Equals a negative 281. All right. Oops, and that's a y, right? Don't forget the y. That's a y. Okay, so now what we're going to do is we're going to want to complete the square, right? And hopefully you recognize these values inside of here after I've factored out that common factor. Now you can say, well, now I can just complete the square, right? Now again, but when you have that coefficient, that's where it's really important. One, students first forget to factor that out because again, we can only complete the square here when my a in this quadratic is 1, but then they also forget to multiply it back through. So when I complete the square here, hopefully you recognize that this would be 2x plus 1, right? That's going to create your perfect square trinomial. But again, you're not really adding a 1, you're adding a 1 that's being multiplied by a 25. And then, so therefore, on this left-hand side, I'm going to write a negative 281 plus a 1 times a 25. And I'm going to write it all the way out, even though I don't really have that space, just because I want you to see where everything is coming from for accounting purposes. Then over here, I'm going to have a negative 16. This would be a y squared minus a 6y, and therefore that would be a plus 9. And again, this is going to be a 9 times a negative 96, or a 9 times a negative 9 times a negative 16, which is going to be a, let's see, 90, and that'd be 42, so 132. But again, let's just do that as a plus a 9 times a negative 16. Okay, now I'm actually going to use my graphing calculator just because I want to make sure that I have everything accounted for correctly. So 9 times 16 plus 25, actually that's going to be a negative 144 plus 25 minus 281. And that's going to be a negative 400. Okay. So that becomes a negative 400. And therefore this becomes a 25 x plus 1 quantity squared minus a 16 y minus 3 quantity squared. Now again, my whole goal here is to make this a positive 1, right? If you look at the general form, for my parabolas, again, if this is going to be negative, it needs to be a negative 1. So I'm going to divide everything by negative 400. Okay, now 25 over 400 can be reduced to the fraction of 25 goes into 400 16 times, and 16, or 400, goes into 16 then 25 times. Now again, notice that this is going to be a negative, right? So this would be x plus 1 quantity squared over a negative 16 plus a y minus 3 quantity squared over a positive 25, right? A negative or negative is going to be a positive 25 equals 1. Now, again, my whole goal here, guys, is going to recognize, again, that this is going to be actually a negative. So I kind of ran out of space here, but technically the way we want to write this in our standard form would be y minus 3 quantity squared over 25 minus a x plus 1 quantity squared over 16 equals 1. And therefore, we can tell that this is a hyperbola. Okay, now that was kind of a lot of work. But again, you can see if we needed to identify the parts of the hyperbola, this would all be the process that we'd want to go through. And now we could identify our center, our H, and our A and our B. Now for this next example, I'm going to try to do the exact same thing, but I'm just going to try to do it a little bit quicker and more efficient. So therefore you guys can follow. And again, I think these numbers are a little bit easier to work with as well. And again, don't worry guys, I do have a shortcut at the end, but this is a process that we are going to be investigating throughout later on this chapter. So that's why I want to get practice now. So again, the first thing we're going to want to do, guys, is organize the X's and the Y's. Okay. And then now we're going to factor out the common factors. So I'll factor out a 4. So that'd be an x squared plus a 6x. I'm doing a lot of 6x's. Plus a 9 times y squared minus a 4y. Equals a negative 36. Okay, now again, we're going to complete the square. So again, you could do b divided by 2 squared, but hopefully you recognize that, like, all right, I'm starting to get this pattern here. This is going to be a plus 9. But again, you're not really adding a 9, are you? You're adding a 9 that's being multiplied by 4. So that's going to be a positive 36. And then in this case, we're going to have a y squared minus 4y. So that's going to be what? A plus 4. So again, you're not really adding a 4. You're adding a 4 that's being multiplied by a 9, which is again going to be another 36. So now that's going to add up to a 36. These can all be factored down into a x plus 3 quantity squared plus a 9 times y minus 2 quantity squared equals 36. But again, we can recognize that if we want to put this in standard form, then we're going to want to divide by 36 on both sides. 4 over 36 is going to be 9. Say 9. Plus 9 over 36 can be written as 1/4. Okay, and there you go, ladies and gentlemen. Now you can see that this has an addition instead of a subtraction between the two quantities. So therefore, this is an ellipse. Okay. All right, so that's all we wanted to kind of practice for you guys, going from general form to standard form, and just make sure you guys can identify. Sometimes it's not always easy to see what it is in general form. So therefore, knowing how to complete the square is very helpful to be able to see that standard form. However, for the sake of time as well as our sanity, this is not the most efficient way to be able to classify each of these conic sections. If I'm only asking you to classify what is it, we're not going to want to go through all the steps. This is a lot. So therefore, we're going to want to remember this kind of rule here. And when you kind of think about this, a lot of students are like, oh, I need to like memorize this. Yeah, you could, but it's really just kind of common sense once you kind of know what you're looking at. So here's the general form for any parabola, for any conic section. I apologize. So a x squared plus b y squared plus cx plus dy plus e. Now again, there is another form where you could have the xy, but we're not going to be working with that in this section. So the important thing is, again, if we only have like one x squared or one y squared, we know that's a parabola, right? Well, that means then a has to be 0 or b has to be 0. One of those is going to be 0 if we only have an x or a y. So therefore, that's why you can see a parabola produces a times b equals 0, right? So again, really, I just look at it is, in this case, I don't have an x squared. So therefore, my coefficient of x squared would be 0. So 0 times 1 is 0. That's why, again, that confirms that's a parabola. For the next one, I think next one to look at is the circle. So when a and b have the same coefficients, then it's going to produce a circle. Because again, remember, a circle has a radius. It's equidistant. All the points are equidistant from the center. There is no elongation vertically or horizontally. So if we look at the circle here, we can see that we have 1 and 1, right? So a is equal to b. That's why it produces a circle. The next one is the ellipse. Now again, if this is an ellipse, remember an ellipse, the standard form of ellipse is we are adding, right? We're adding those two quantities. So if you have two positive quantities, like a and b are both positive, right? If you're adding, well, if you multiply those, that's always going to produce a positive value, right? If they're both positive, the product is going to be positive. So that's why you can see an ellipse is just going to be a times b. If it's greater than 0, it's an ellipse. So here's our example of an ellipse. Our a times b is a positive 36. You can see why that is an ellipse. Where on the second case, the hyperbola, where again, remember that was one quantity subtracted from another quantity. So that's the difference. Either a or b has to be negative. One of them is going to be negative. So when you multiply a positive times a negative, you are going to get a negative value. And you can see again, in this case, my 25 times negative 16, doesn't really matter what it is, it's negative, right? So therefore you can see that's a hyperbola. So let's just kind of go through a quick little classification here to wrap up our lesson. So basically all I want to do is just label our a and our b. So 2 times negative 1 is less than 0. So therefore this is a hyperbola. In this case, I can say here's my a and I do not have a b squared. So this would be a times 0, which is equal to 0, right? Because it's b times x squared, which is 0, x squared, right? Because there is no x squared there. So 8 times 0 equals 0. So therefore, this is a parabola. And again, it's not really something you need to memorize. It's like if there's only one squared, it's a parabola. For the next one, my a and b are not the same, but you can see that a here is 1 plus, here is my a, and that's my b. So when I multiply a times b here, in this case, I have a 1 times a 9, which is greater than 0. So therefore, you can see that this is an ellipse. And the last one here, you can see that here's my a, here's my b. So 2 is equal to 2. So therefore, that is a circle. So there you go, ladies and gentlemen. That is how you classify in general form. You can see that was a lot easier than actually having to complete the square. But don't feel like this completing the square was a waste of time, because once we dive into working with each and every one of these conics in our individual lessons, you'll see this process coming up. So that's why I wanted to make sure we spent our time in today where we had a relatively simple lesson. But anyways, guys, that is it for this chapter. And feel free just to go ahead and just do a reflection that I always like to end the class with as far as what students would understand, what they did not understand. And always feel free to comment down below and let me know how this lesson worked for you. All right, guys, I'll see you on the next one. Cheers.